In the last video, I talked about the plain old Java object, and I showed you how it comes with a lot of boilerplate code. It's the code that's repetitive and follows certain rules. In my case, I had a constructor with parameters for every field in my class, as well as getters and setters for each field. I also set up a toString method on this class, so I could print out all the fields in my class in a nicely formatted way. This is the code that's repeated over and over for every Pojo or for every Java Bean if you're using Java Beans to leverage Java frameworks that use them. Once created, this code is rarely looked at or modified. In fact, there are tools that'll just regenerate all of this code if your underlying data or domain model changes. It's time now to discuss what I think is a better alternative to Pojos, the record. The record was introduced in JDK 14 and became officially part of Java in JDK 16. Its purpose is to replace the boilerplate code of the Pojo, but to be more restrictive. Java calls them plain data carriers. The word carrier is an important term because it means the record has more rules built in than a Pojo would. The record is a special class that contains data that's not meant to be altered. In other words, it seeks to achieve immutability for the data in its members. It contains only the most fundamental methods, such as constructors and accessors or getters. Best of all, you, the developer, don't have to write or generate any of this code. I'm back in my record project from the last video. In that video, I created a student class with a constructor and some getters and setters. I then used a for loop to create 5 students. If you didn't watch that video, you can get the code from the resources section of that video. I want you to be able to review the student class next to the record I'll be creating, so please try to have the code in front of you from where we left off in the last video. I'll expand the project panel and right-click the SRC folder because I want to add a new Java class, but this time I'm going to pick record instead of class that I've been using up until now. You'll see there are other options like interface, enum, and annotation. And I'll be talking about those eventually. Right now we care about the record type, and I'll give it a name, LPA student. LPA stands for the Learn Programming Academy, and then student. Now, you can see this looks a lot like a class. It starts with a public access modifier, but instead of the class keyword, it's using the record keyword. Where's the magic, you ask? It's hard to see at first, but different to a class, you'll notice that in this code, there are a set of parentheses after the name of this record, LPA student. Similar to a constructor, I can set up some parameters within those parentheses. I'll set some up so that the parameters are the same as our student class parameters. In fact, let me just copy that parameter list from the student class constructor. I'll pop over to student.java, copy the parameter list I've set up in that first constructor, then I'll come back over to LPA student.java and paste those parameters in the parentheses. And that's it. I'm ready to use this record now in my code. It's really that simple. I'll go to main.java and show you. Before I make any changes, I'll run the main code as it is. And you'll remember I get the output from the toString method I generated in the student class. Now, I'll use my new record. I'm simply going to use LPA student in place of student in the code here. I need to change both references on line 6. This code compiles, and if I run it, the output we get uses square brackets instead of curly braces, but is very similar to the previous output from the Pojo. Let's look at these two source files side by side. I've replaced the 56 lines of code that I have in student.java with these 2 lines of code in LPA student.java. The record LPA student doesn't have or support setter methods, but the other functionality, calling the constructor with 4 parameters and printing the data out, is implicitly part of the record. What's really happening here? What does Java tell us about what is implicitly created when we declare a record as I did in this code? First, it's important to understand that the part that's in parentheses, this entire part, is called the record header. The record header consists of record components, a comma delimited list of components. For each component in the header, Java generates a field with the same name and declared type as the record component. It sets up fields for us as we have them in the parentheses. These become the fields of the record. The field is declared private and final. I'll be talking about final more later, but simply put, it means the field can't be modified. The field is sometimes referred to as a component field. Java generates a toString method that prints out each attribute in a formatted string. In addition to creating a private final field for each component, Java generates a public accessor method for each component. This method has the same name and type of the component, but it doesn't have any kind of special prefix like get or is, for example. The accessor method for ID in this example is simply ID parentheses. This is easier to show you in the code. First, I'll drag lpa-student.java back over into the other window, get rid of that side-by-side view, and I'll open the main .java code. Now, I'll add some extra code after my for loop. I'll create two students. One will use my Pojo class and one will use my record. Let me set that up. Student, Pojo student, equals new student, and in parentheses, the following literal strings separated by a comma, S923006 and the 5th of November 1985 and Java Masterclass. LPA student, record student, equals new LPA student, and another set of literal strings separated again by commas. S923007, comma, Bill, comma, the 5th of November 1985, and finally, Java Masterclass. Okay, so now let's print some information out about each of these students. Println Pojo student, println record student, and if I run that, you can see my two new students at the end of the output. Notice the minor differences in the output. This shows us that like IntelliJ's generated method, toString, the record is printing information out similarly, though it doesn't include single quotes around strings and the brackets are different. Now I'll just print out a couple of the attributes myself using the accessor or getter methods. I will do this first for my Pojo student, println, and in parentheses, Pojo student.getName, plus the literal string is taking plus, and Pojo student.getClassList. And I'll copy and paste that line replacing Pojo student with record student in both cases. Now you can see I have compiler errors for getName and getClassList on that new line of code. I stated in the slide that Java's implicit code doesn't include the prefix get and simply uses the same name as the component or field. Let's remove the prefix and change the case of name and class list to use lower camel case. And now I can run that. And I get the outputs. Anne is taking Java Masterclass and Bill is taking Java Masterclass. That's how we use accessor methods, which I've called getters up until now, because traditionally the prefix get was used for the accessor method. And finally, let's see what happens if we try to set data on these two types of students. Let's say they both added a class, my Java certification course, Pojo student.setClassList, and in parentheses, Pojo student.getClassList, plus the literal string, comma, Java OCP exam 829, record student.setClassList, and in parentheses, record student.ClassList, plus the literal string, comma, Java OCP exam 829. And here you can see the line for record student doesn't compile. It doesn't have a setter named setClassList. In fact, it doesn't have a setter at all. There is no way to set the class list other than by passing the value in on the record header or through the use of constructors. This is by design because a record's goal is to be immutable. I'll comment out that last line of code and run my main.java class again. And here you can see for my Pojo student, I could modify the class list. Why is the record built to be immutable? There are more use cases for immutable data transfer objects and keeping them well encapsulated. You want to protect the data from unintended mutations. If you want to modify data on your class, you won't be using the record. You can use the code generation options for the Pojo, as I showed in the earlier video. But if you're reading a whole lot of records from a database or file source and simply passing this data around, then the record is a big improvement. I've only touched on some of the features of the record to give you an introduction. When I do talk more about the final keyword and immutability of data, especially as it may be affected by concurrent threads, we'll be revisiting this type. I'll also be showing it to you in action when we get to the database and I/O sections of this course. In this section of the course, up until now, I've introduced you to the class as the building block for object-oriented programming, and I've talked a bit about encapsulation. In the next set of videos, I'm going to cover another key feature of Java's support for object-oriented programming, and that's inheritance. Let's get started on this in the next video.